the tap into the fleet to access the exact data that can fix the problems. But raw data is not sufficient. In order to train these networks, you need labeled data. You need labels to supervise the networks. And if you only depended on the human labelers, this data would be too tiny to train these large multi-camera video modules. We need lots and lots of data to train these networks. Hence, we have built a sophisticated auto-labeling pipeline that collects data from the fleet, runs computational algorithms in our data center, and then produces the labels to train these networks. Here, you are seeing a 3D reconstruction that is happening by collecting various clips from different cars in the fleet and assembling them, all of them together into a single unified representation of the world around the car. You can see all the lanes, the road boundaries, curb, crosswalks, even the text on the road being accurately reconstructed by these algorithms. We don't have to stop at this kind of reconstruction. Once we have this base reconstruction, we can build various simulations on top of it to produce an infinite variety of data to train for all the corner cases. We have a capable simulator that can synthesize adversarial weather, lighting conditions, and even the motion of other objects to test all the corner cases that might even be rare in the real world. Here's an example of why this data is critical and how we can solve problems using data. So back in the days, for example, in this case, we had some false braking where we thought this car that's actually parked there was going to move into our path, and hence we were precautiously braking. But it is unnecessary because the car is truly parked. So how can we solve this? What we did was we mined the fleet for similar cases where the car had false braking due to some parked car. We added 14,000 videos to our training set. And then once we trained the networks again with this new data, it now correctly understands that, OK, there is no driver in this car, hence it must be parked, so then there is no need to brake. And this is a systematic way to solve problems. On the chart on the right side, you can see that every time we add data, the performance improves. And then we can do this for every kind of task that we have in our system. And this is what we call as data engine. We identify challenging cases, such as the one you saw earlier. And there could be other different types of challenging cases, too. We mine the fleet for such data, put it through our auto-labeling system, and produce the labels, add it to the training set. And once we have the newly trained models, we deploy them to the fleet. If we rinse and repeat this process, everything gets better and better. The final critical piece is the compute. In order to train these large models in a reasonable amount of time, you need lots of compute. In addition, compute is also required to produce the labels automatically. This is just compute in our data centers. In addition, we also have high computers in the car, which can run up to like 150 teraops of compute. On the back end, we have a 14,000 GPU cluster, and roughly 30% is used for auto-labeling, and the remaining 70% is used for training. We also have a 30 petabyte of video cache, and this is growing to 200 petabytes. All of this is going to significantly increase once we bring Dojo, which is our training computer, on board into this. Just to give a reference, just the occupancy networks that you saw earlier use 1.4 billion frames to train these networks. We have already shipped our FSD beta software to pretty much everyone that has bought it in United States and Canada. This amounts to roughly 400,000 customers who can turn it on anywhere, and then the car would attempt to drive to the destination. It's still supervised, but it can already handle turns, stop at traffic lights, yield with other objects, and generally get to the destination. We have observed that people who use FSD are already 5 to 6x safer than the US national average. Like I mentioned earlier, the solution to scalable FSD is getting the AI architecture, the data, and the compute just right. And we have assembled a world-class team to execute on this. We are pushing the frontier on these three items, and as we improve the safety,